dum 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 up, and there's the missus right now. Hopefully she only calls my name once, and then goes back to whatever she was doing. Okay, let's, hold on. I'm doing a live stream! Your channel. Up, there I am. Doing my live stream. And we've already got a chatter. Pop out chat. Hi! Jaden Hamilton. Okay, hopefully. Hi again, Jaden Hamilton. Okay, let's start a new career mode. We're gonna call this It's Alive. Difficulty normal. Yeah, that sounds good. And because our why not use the weird no, let's see. What's a good logo for us? It's alive. Winter owl. Okay. Yeah, sandbox. All right, start. Hi. What is this game? This game is Kerbal Space Program, and you'll see what it is. Nice to meet you. I'm Gene Kerman, flight director and your guide to this quick introduction. This is the Space Center. From here you can manage all aspects of the space program. Feel free to have a look around. Hold the right mouse button to move... Wait a minute. I must have started a sandbox mode. It's supposed to be career mode. It always takes so long now to load. So Kerbal Space Program is kind of like a physics simulation game. You design, build, and launch your own spacecraft and fly them around and do cool missions and stuff. So we are deleting It's Alive. Yep. And we are going to start a new career mode. It's Alive. Okay, that's all good. There we go. Career mode. Career mode. Alright. Let's see what Gene Kerman has to say now. Is it the exact same diatribe? Nice to meet you. I'm Gene Kerman, flight director and your guide for this quick introduction. This is Space Center. From here you can manage all aspects of the space program. Feel free to look around. Use the right mouse button to move the camera or use the arrow keys. Well, weird. Okay, or use the arrow keys. Right-click over the Space Center facilities to learn more about them. Left-click when you're ready to head inside. If you need more information, check out the training on the main menu. I think so, I've got it. Let's go mission control. Let's gather scientific data from Kerbal and launch our first vessel. That'll be our first mission. Alright. We're gonna go in here. Oh, obviously we can't do anything in there. So let's go ahead and launch our first vessel. I wonder if there's any interesting parts that we can use off the first tier that were from any of the expansion packs. Obviously, we've got the Onion re-entry module. That's a unique part to making history. It is slightly less weight than the Mark I command pod. Let's go on to no liquid fuel tanks yet. We got a fully solid rocket booster. We've got that structural piece. We have a basic fin. Interesting. That is locked. Okay. Wait. What? Oh, cannot be the first part of a vessel. So if we go ahead and select our first command pod, let's give it 0 monopropellant because we can't use monopropellant anyways. Let's go ahead and give it a parachute. All right. Now the way that you plan, are you on Twitch? No, I'm not on Twitch. I'm just not. Maybe I should. Maybe I should figure that out and get a Twitch account going. It's just gonna take time to like research how Twitch works and how to create an account there and all that. And really, I only chose to do this on a whim. I'm like, hey, I've got half an hour free. Let's do this. So, okay. I've got those. You know what? Let's do 3 of them. Yeah, that's a good idea. I think I need 3 of them. And then we got our solid rocket booster. Let's tone down that thrust a fair amount. Let's go 50%. Plenty of thrust. We'll do that. And I want to throw my rocket out towards sea, so I'm rotating it that direction, so it goes out towards the ocean when I pull up on the stick. Okay. Am I missing anything at all? No, I am not. Let's go ahead and we're gonna put a scientist in first. Nah, we'll just do a jab. We want a pilot. We want a pilot to gain some experience going on this little short hop. Let's just do throwy thing. That's the name of our craft, and we're going to save it, and we're going to check our staging. Now we're going to save it. Now we're going to launch it. And we currently want to maximize the amount of scientific data that we get, so we can get from the launch pad, flying, and the splashdown in the water. We can get all 3 of those. We can get all the experiments that we can currently do from all 3 of those biomes, so that is what we are going to do. The only thing we cannot get is an EVA report while flying. So, crew report, good. We'll observe the mystery goo, great. And then we're going to go EVA. We're going to do an EVA report. We're going to board back into our spacecraft. Okay, that's all the science that we can do from the launch pad. Now we're going to launch this. We're going to tilt over. Alright. Just let it fly on this little ballistic trajectory. Woo-wee! Look at it go! Yay! Yay! Fly! 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 It's going fast. Ooh, pulling 4 Gs. Alright. Now, we'll observe Mystery Goo again. Flying at Kerbal, it jiggles and wobbles as the craft flies. Excellent. We're going to do a crew I forgot to do a crew report while flying. It's okay. That's a common experiment, so I'm not really worried about not being able to get that experiment. You know what? Let's go ahead and do it. And we will overwrite, and we will get another quick crew report. Let's hopefully these fins don't lock me. I don't want to be pointed down. I do not like that. No! No, because then I'm going to be going too fast. Okay, maybe I can get it here. Okay, come on. Well, that parachute will stop me. I think I'm going slow enough. Woo! there we go, as the parachute fully opens. Excellent. Let that dangle down and splash down in the water. Ooh. Let's see, how many people are in this chat? I don't know. I wish I had statistics. Whoa! Forgot to slow down the time acceleration there. Let's go ahead and observe that mystery goo. We're going to do an EVA report. We're going to take that data. We're going to do a crew report. Oh, wait. No, we got to do an EVA report here. Now we got to do a crew report there. You know what? One thing I can do? I actually can climb back up onto the ship. Okay. I actually can get an EVA report while flying. Flying over Kerbal's water. Excellent. Climb, climb. Okay, getting back on that ship might be tricky. Hey, I did it. Board. And recover vessel. And then we'll just quickly launch vessel again and recover it with the crew report from the launch pad to get all the science that we can before moving on to our next mission. Okay, so we'll just do this. Launch. Excellent. Oh man, loading takes so long now. I don't know what it is, but those expansion packs or my computer being slowed down, that's crazy. Okay, crew report. Excellent. Recover vessel. Good. We've gotten pretty much all the science that we can from those areas. Yep. Yep. We'll just pretend we did that on one mission. Alright, so I've got 50 science, a whopping 50 science. We want to get as much science as possible right now, so we're going to go ahead and research that. We might as well also research that. We've got 30 science left. It's nice to have some liquid fuel engines, certainly. Because otherwise, you know, it sucks. Yeah, we can go ahead and research that. We have a liquid fuel engine, we just don't have any reasonably sized fuel tanks. We could do that one too. 25, yeah, let's do that. Okay, so now we have enough parts to do an orbital mission, if we so choose, which, let's go ahead and do that. Let's do an orbital mission instead of that short little, not even leaving the atmosphere suborbital hop. So our next mission is to leave the atmosphere and fall back down. Let's put 2 of these in. Yes, that's good. Because we are worried about weight here. You know what? I don't think I need a heat shield just to come back from orbit. So, say we're really worried about weight. Let's go with 3 of those. And this gives us 1,752 meters per second at altitude 0. That's 2,230 meters per second. Excellent. Go ahead and have a decoupler there, and we're still under our target mass value. I think this will get to orbit. But just to make sure, that should definitely get to orbit. That's got 3,700 meters per second. Yeah, that should get to orbit. Should. Operative word, should. Of course, if I put that at sea level altitude, okay, so it looks like we'll probably have about 1,000 meters per second in that first stage, and then the second stage, we'll have a significant amount of delta V, probably 2,500 meters per second. That's 3,500 meters per second delta V. If I take a good launch profile, keep things all aerodynamic, I should make it to space. And back again. Oh, right. And you know what? Actually, one thing I'm going to do here, I'm actually going to make things a little more complicated. Okay. We're gonna get science. Okay. Alright. There's that. Okay. Ta-da! We've got things. We could put an antenna on it, but I don't want to. I want to say wait. Okay, and let's go ahead and put this decoupler here, so we're not having to save. You know, why not put it on the damn thing? Doesn't add much weight to that, and that should be good. Let's see, 14.82 tons. We probably have enough margins. We could put on this. Yeah. And we still have 5.120 tons left. Here, this will absolutely, definitely get us to orbit. No question about it. That's our rocket. 600 and... Oh, what's going on here? Light that up. Then decouple that and do that. Then... There we go. 808, let's see. Okay, average altitude, 20 kilometers. Okay, 882 plus 693, that's what? 1,521. 1,521, so we're at 3560 meters per second. I think we're good. Yeah, let's go ahead and do rigid detachment on all those. Do I not have advanced tweakables on? What's going on? Maybe because I don't have any struts unlocked, so I can't do auto strutting. I've got to strut my stuff. Okay, rigid detachment is on all of that. Rigid detachment, rigid detachment, rigid detachment, rigid detachment, rigid attachment on, rigid attachment on, rigid attachment on, rigid attachment on. Let's go rigid attachment on there, rigid attachment on there, and why not? You know what? We're gonna increase that altitude to about 1,200 just in case there's any trouble coming down. We also want to remove any monopropellant. We don't have any. I'm gonna change the color of these. They're gonna be white. No. Orange, black. How about that one be black and white? This one be orange as well. So it looks like a bipropellant rocket with equal volumes of oxidizer and fuel. Cool, that's a pretty cool rocket. I think it's going to get us where we need to go. Let's check back aerodynamics. Yeah, let's add some fins on this stage for good measure. Increase the amount of fins on this stage for stability. And we are still within our weight margins. This thing is ready to go to orbit. We've got a pilot in there. We're gonna call this thing Big Circle Fly Thing. Fly-you thing. Fly-y thing. There we go. Spelled fly right now. Okay, save. Launch. Black screen. Black screen. Black screen. Black screen. Black screen. There's my dog upstairs running around. But you might not be able to hear that because I've got a good microphone that's right next to my mouth. Okay. And launch. Woo! Look at it go. Barely accelerating, but still accelerating nonetheless. Give it a little bit of tilt. Little bit of tilt. Just a tad there. Because that's going to exaggerate. And then turning off stability. Let that fly on a ballistic trajectory-ish. And I gotta give it more tilt. More tilt. More tilt. More tilt. Yeah, there we go. Ooh. Oh, come on. I'm gonna only fire up my engine when I get to 45 degrees. Fire up my liquid fuel engine. I don't know if I have enough delta V for this. Ooh, I'm starting to worry. Oh boy. Whoa, no! That's not good. Okay. Oh my god. Do I have the margins to get to orbit? And come back. That's the other thing. I gotta be able to come back. Which, I don't know. Let's see. Apoapsis 54 kilometers. That's fine. Okay. So far, so good. It's gonna be a low orbit. Don't want to go more than 72 kilometers up. Okay, 555 meters per second. Whew, I don't know. I don't know. It's gonna be close. It's gonna be close. It's gonna be... Oh shit, I'm not gonna make it. No! No! Unless I do a little bit of EVA manipulation here, which may be possible. I might be able to push that capsule to orbit, but I'll have to go back to the Space Center and upgrade the astronaut complex. Yeah, we're going to train you how to get out and push mid-flight, Jeb. Because I don't think I'm going to make it. Not going to make it. Buddy. Well, I got the space. Yep, that was it. That was it. And my periapsis is at 13 kilometers. So it's not going to happen. This is just shy of suborbital because I wasted too much fuel rising at too steep an angle in the atmosphere. I believe that's what happened, what went wrong. But I can get some successful science out of this mission. Log temperature, log pressure data. Let's do a crew report. Excellent. Let's go back to the Space Center while he's still in space real quick. Upgrade that astronaut complex. Yeah, let's do that. Oh, come on, come on. I've only got so much time before he hits the atmosphere. And if he hits the atmosphere... yeah, I can do that. I can afford that. If he hits the atmosphere, then I can't get science from space. Right? So, gotta fly. Gotta fly. EVA unavailable, but I there we go. EVA report. Cool. And let's go ahead and take that data. Collect that data. Take that data. Take that data. And oh, I forgot that it takes a scientist to reset that canister, so things will just have to wait around. Okay. I'm going to be hitting the atmosphere soon. Let's see, where am I going to land? Oh, I can't even see. I am in the atmosphere, slowly turning. Yeah, I could time accelerate, right? I'm just letting the natural rotation of my spacecraft point me in the right direction, and then I'll jettison the stage. Okay, that works. Okay, I think that's stable. Oh, I put that heat shield on, and the heat shield is filled with ablator. And really, I only needed like the smallest amount of ablator, probably. So, if I do that, that might be enough. I might need more fuel anyway, though. Well, no, if I just do a better flight profile, and I take off some of that ablator, I should be able to get there. Yeah, won't be a problem. It'll be cool. But you know, we'll see what we can buy with this new science. Maybe I can get something schmancy. Okay, let's time accelerate going through this atmosphere. No need to bore you guys out of your mind. And, you know, we're going to see fire here pretty soon. I hope I don't land on mountains. That would be bad. For a second there, I thought my heat shield had burnt off. It looked bad, didn't it? In fact, you cannot see the heat shield. That's weird. Why can't you see the heat shield? That is so weird. But it's there. Okay, we're hitting 3 Gs. Can't tell what we're over. I think we cleared the mountains along the rim of that big crater. It's hard to say what happened, but we are falling quickly through the atmosphere. 4,000 feet, 3,000 feet, 2,000 feet. Ooh! I forgot that that should be... Oh my gosh! You better slow down! Whoo! All it did was destroy the heat shield. That was intense. That was insane. Okay. Woo! That was a close call, Jeb. I think you're in the Highlands. Okay, so let's do an EVA, and we'll take that data. We'll do a crew EVA report from Kerbin's Highlands. Let's do another EVA report. No, wait. I have to store that experiment. Now let's do another EVA report while we jump, while flying. Yeah. And then go ahead and open that. Ta-da! Hey, neat. It stood up. Okay, we're going to... Oh, wait. No. We're going to log that temperature. Oh, right. You're not a scientist, Jeb. You just pretend to be one. You're a pilot. You're just a dumb pilot. Get inside your spacecraft. Now log the temperature. And now log the pressure data. Yeah, and now let's recover the vessel. We got a fair bit of science from that mission. Not all the science we could have. If we had a scientist on board, that would help. We could have reset some of those experiments and so forth. But yeah, it's not overall not too bad. Where are my analytics? There it is. Analytics for my current live stream. Wait a minute. Go live. There we go, live dashboard. Aha! Don't need that anymore. Okay. Let's see. We are at... Oh, it's been half an hour. Just play a little bit more, and then we'll be done with this live stream. Okay, we got... we can do in stability enhancement. We can get... Oh, Mobile science lab. We're absolutely getting that, even though it's expensive. Can't really do anything else, so let's go ahead and get that stability enhancement and leave the facility. We'll go back to mission control. We've left the atmosphere, so we might as well bring on one more contract. Test heat shield at the launch site. That's easy. Test hammer booster at the launch site. Maybe. Ferry 2 tourists safely to their destinations and back. Haul flea solid booster into orbit of Kerbal. Test Mark II parachute in flight over Kerbal at an altitude of 8 to 12,000 meters, between 180 and 270 meters per second. I think that's doable. I think my craft will slow down to that speed by that time. So I'm going to go ahead and accept that contract. It is the most prestigious. So we can't do any more science. I think that's good. So let's go ahead and let's not build another ship, but let's open a ship that we already had. Big circle fly thing. Yeah, that's it. That's the one that we want. Okay, we got that. Now let's see. We're going to give that a blader like just 20 abladiness. 20 ablader. We don't need that. This would be nice. It's going to add 0.2 tons onto our vessel, but it would be just so very nice. So I'm going to get it. But I'm going to put it underneath this stage, so it's going to get discarded. Which means if we want to get to space, we're going to need more meters per second. Delta V. (3,532 meters per second at 20 kilometers). Okay, that was not enough. Pretty sure that was not enough. So, an option we could just like forego some of that science for now. We have 3,629 meters per second. That helps. We can add another fuel tank, and now we've got 3,889, but our tonnage is a little heavy. There's a thing about that. I bet if we just reduce the amount, there we go, 17.79. 3784, or we go 3658. No. How about this? 3749. So maybe if we do this. There we go. 3787. What was it if we did this? 3784. So we get actually slightly more delta V by configuring it like that. And I believe that this should be enough delta V for us. to get to orbit and fulfill our contracts. And we've got this that thing, so we're good. Big fly thing. Yeah, we'll just save over that ship. Big fly circle thing. Hey, there's somebody else watching finally. Yay! Or was that somebody's stat? Yeah, that's a new viewer. Cool. Hi. Alright, so we're going to turn on stability, turn our thrust to maximum. This time we're going to roll over a little bit early, because last time we did not roll over enough. Now we might have rolled over too much. I hope not. Go faster, faster, so that you don't roll over as much. Oh god. Rolling over a ton, you know that, right? Don't do that. Oh, don't do that. Don't do that. Don't do it. Don't do it. Don't do it. Oh, don't do it. How much electric charge do I got? Plenty. Okay. Okay, I can maintain... keep it from rolling over too much a little bit there. Once this runs out of fuel, I'll have definite authority. Actually, you know what? This flight profile is not bad at all. I'm just going to relieve. And there we go. There we go. Good flight profile. Good flight profile. I'm just going to follow that prograde vector all the way to orbit. Yeah, I know there's fire coming off of my ship, but it's not as bad as it looks, I promise. Okay, do I have an apoapsis above the atmosphere? I do not. Let's bring that apoapsis above the atmosphere. Shane Arnold says, hi! Hi, Shane Arnold! Okay, we got 70.82 kilometers. Excellent. Let's, for good measure, just bring that up a little bit. There we go, 76 kilometers. Out of the atmosphere. Not on Earth, but on Kerbal. Yes, we are out of the atmosphere. And we're just going to coast here for a while till, let's see, we're at 1,600 meters per second at apoapsis, roughly. So we're just going to coast until apoapsis is... Oh, it doesn't give me that data. Hey, we got 2 viewers. And Shane Arnold says, thank you for what? Oh, for saying hi to you? Okay. You're welcome. Here we go, 76 kilometers, and let's just get a little closer to that apoapsis, shall we? We're high enough in the atmosphere, we don't need to worry about aerodynamic forces. Get a little closer to that apoapsis. Almost there. Okay, now target prograde and light her up. Circularizing the orbit. We're gonna get there. Yes, we are indeed. This time we're getting to orbit. Shut down a little bit as that apoapsis was getting away from me. We've got 625 meters per second. We can get to orbit and then some. This is pretty awesome. Oh, everybody has just left. Everybody left. Everybody hates me. Okay. It's alright. It's alright. I'm just going to make the most circular orbit possible. "70 kilometers. We are in space. We have achieved orbit. And we can go ahead and not everyone hates you. Hey, wait a minute. Said my viewers had dropped down to 0. How did you hear that? Okay. Observe materials bay. We're gonna get materials science from space. We're gonna do, well, no, we don't need to do a crew report now. Well, we've already hit orbit. We might as well deorbit. Let's deorbit with style. Let's use up all of the fuels. All the fuels. Uh-oh. Does that put me on the rim of the canyon? I hope not. Okay, I think I'm gonna splash down in that big crater lake. Okay, now that you have orbited Jeb, you should get pilot wings and should be able to target prograde vectors. Yay! It's magic! It is magic. Actually, I believe Arthur C. Clarke wrote that any sufficiently advanced technology is indistinguishable from magic. In fact, if you think about it, what does magic mean? Well, nobody knows what it means, right? It's stuff you don't understand. That's really all it is. It's methods of accomplishing things that you don't understand, and therefore magic. That's the definition of magic. So if you went back in time and you showed people electricity, well, you really are conducting magic to them. You know what? Let's get a quick EVA report from the upper atmosphere. All right, awesome. Crew report 2 from the upper atmosphere, and let's hope that I don't land on the rim of the crater. I should land in the ocean. It's hard to see the ocean though. So we're going to time accelerate into the atmosphere. Falling. Oh, I don't know if we'll hit our goals for the contract. We got to be between 8,000 and 12,000 meters in altitude. And we have to have a velocity between 180 and 270 meters per second. We'll see if we meet each of those criteria as we fall through. Let's time accelerate until we're close to that altitude. 17, 16, 15, 14, 13. "12 kilometers. Speed is dropping. Is it dropping fast enough? Oh, it sucks. I'm so close to terminal velocity. I think... Hey, we got it! Activated the parachute. We achieved the goal. We earned lots of money! Lots of money! Okay. Time accelerate until we come close to 1 kilometer altitude. 2, 1. There we go. Let the parachute open. Ooh, slowed us down. Okay, time accelerate again. Until we splash down. Hi, I'm back. Hi, Jaden. You guys should be asking more questions about this game, or really about anything. I don't mind answering whatever questions you might have. It would make the stream more interesting, wouldn't it? Yeah. By the way, I should probably know the age of my audience. Make sure I can... what kind of jokes I can make. Let's go ahead and do an EVA report. And, oh wait. Take data. Board. Crew report. Oh, okay. Well, let's just recover that vessel. 17 playbacks. Cool. 1, 2, 3, 4, 5, 6. Huh. Average watch time, 1 minute and 12 seconds. Oh, isn't that nice? Okay. So, we did a lot of good science. Maybe before we buy our parts, we find out what kind of mission we're going to go on. Oh, explore the moon. Ooh, I'm not sure if I can do that. That'd be cool. Okay, fly by the moon. I could do that. Why not? We got 64, but we need 90 to get to that tier. So we are going to need this if we're going to fly by the moon, or we do a manned flyby of the moon. If we're going to do that, we definitely want this engine and this fuel tank. So we're going to buy that. Let's see, I don't have any more science to spend. But I do need to upgrade my launch facility. And let's upgrade the launch pad too. Okay, now it is time to do a moon rocket. Moon rocket. Let's go ahead, ditch this thing. We're gonna call this moon. Looks so big. Because it'll look so big as we fly by it. Oh my god, it's so big. Okay. I have a question. Do you know what E equals mc squared means? Yes. Energy equals mass times speed of light squared. That's not just me reciting it. I actually know what the equation means. It means that there is a certain amount of energy in matter itself. The rest mass of matter is proportional to the energy in matter is proportional to its rest mass times the speed of light squared. Now, speed of light is obviously a very big number. So, this is the mc squared is actually twice the kinetic energy that object would have if it were traveling at the speed of light in a Newtonian reference frame. In Newtonian physics, there is no speed of light. There's just, you can accelerate and just keep going faster and faster and faster. In relativity, which is the universe that we live in, there is a limit to how fast you can go, and that is the speed of light, which is the speed of causality, basically. So, yeah, there's a tremendous amount of energy in matter. And not only that, the more energy that is in that matter, the more massive it is, because energy equals mass, right? So a charged battery actually has a very, very tiny amount of energy, or weighs a very, very tiny bit more than a discharged battery, even though it has the same number of atoms. It actually has a slightly higher mass because of the chemical energy that's stored in the battery. Normally, this is not measurable. However, there are elements in the periodic table that have a tremendous amount of fission or fusion energy stored within them. Fission and fissile energy. Uranium, for example, uranium-238. If you look at a periodic table of the elements and you look at the atomic mass for uranium, it is 238 point something something something. But it's more than 238. That's important because why is that important? Well, actually, if you look at the isotopic distribution for uranium-238, or for uranium, there is no uranium with an atomic mass more than 239. So how could its average weight be more than 238? Excuse me, 239 or greater. Almost all of the isotopes are U-238, some are 235, and some are 234. obviously, those lighter elements are at a very small concentration, but how could the average mass be greater than 238 if there are no elements heavier, or no isotopes heavier than 238? And that is because there is so much energy stored in the nucleus of a uranium atom that it actually weighs more. It weighs more by like 1 part in 10,000, but it does weigh more. Yeah, it's a tremendous amount of energy. I've got the missus calling me. I'm in the middle of a live stream. Okay, I'm gonna have to shut down this live stream. We're gonna have to save this for another day. Thank you so much for joining me on this live stream. It was